So what we have seen is how do you draw a line when you have an equation? But how do you get the equation from just a random set of data like this? If you were going to draw this line by hand, you would try and get through the middle of all of the dots. So mathematically, that's the same thing that we're going to do, and I'm going to show you how. All right, so here's a data set that has 4 points in it. These are 4 students, and on the x-axis, we have how many hours they spent watching TV, and on the y-axis, we have what score they got on the quiz. So for student number 1 over here, we see they didn't watch any TV, and they got a perfect 10. Go them. All right, these 2 students, they both watched 5 hours of TV. One of them got, a 5 on the quiz. The other one, they scored a 0. And then the last student over here watched 10 hours of TV. They were really binging that latest series, and they got a 5 on the quiz. Not too bad. If we took the mean of X and Y for this data, we'd find that on average, these 4 students watched 5 hours of TV, and they got an average score of 5 on the quiz. So let's talk about how to draw this line. All right, so what's happening here is, remember that our equation for our line is y equals beta 0 plus beta 1 times x. So this is beta 1, which we're going to calculate here. And this is the equation for it. I know it looks intimidating, but it's actually not too bad. We're going to break it down. So the top part up here, which is the numerator, is the product of 2 distances. What does that mean? Look at how similar it looks to kind of our formula for getting the error, right? We're taking the mean of x right here and the mean of y over here. Remember the episode, a bar on top, that's the mean. So for each student, we're going to take how far they were from that mean on the x-axis and how far they were on the y-axis. We're going to multiply those together, and then we're going to add them all up. Okay, that's the numerator. The denominator is down here, and this should also look familiar. It's the sum of squares, right? Because we're taking the sum of square errors, we're taking each x, subtracted from the mean of x, and then we're squaring it. And we add those all together. Remember what happens when we square all of our errors? It's always positive, right? So this denominator down here is always going to be positive. That means that the sign of the slope overall is going to be determined by this numerator, the distance from x and distance from y. When both distances are positive, positive times a positive is a positive number. At the same time, when both distances are negative, the slope is also going to be positive. A negative times a negative is a positive. But when one distance is negative and one is positive, or vice versa, then that slope is going to be negative, because the positive times the negative ends up being a negative. Let's show you an example of that. So over here, what we see are some distances, and we're going to look at the value of this distance right here. Here's the mean of x and the mean of y. The distance in both cases is positive, so that this dot, when you multiply those 2 numbers on the top together, it's going to be positive, and all of those are positive, and so our slope is going up that way. But in this case, one of the distances is negative while the other is positive, so that means we're going to have a negative slope. So this is just a demonstration of that. All right, let's get back to calculating our slope. First, we get the distance of each x from the mean of x. So that's in blue. Then we're going to get the distance of each y from the mean of y, and that's in red. So we show our means with this blue bar for x and with this red bar for y. So for our first student, in terms of x, which is their hours of watching TV, they watch TV 5 hours less than the average number of TV watching. So they get a -5 for their distance from x. Their quiz score was 5 points higher than total average quiz score, right? So their distance from y, the quiz score mean, is a 5. For this student right here, they were at the mean for both numbers. They got a 5 on the quiz and they watched 5 hours of TV. So they're just totally, you know, perfectly average student right here. So their distances are both 0. And then for this student down here, they watched 5 hours of TV, which was the mean, so their distance is 0 for TV, but their quiz score was negative. Their quiz score was 0, so they were 5 below the average, so they get a -5. And then for this student, they watched 10 hours of TV, so they were 5 more than the average. That's their distance for X. And then for their quiz score, they got a 5, which was the average. So they have a 0 for the distance from Y. So what we're going to do is multiply each of these distances together. So -5 times 5 is -25. 0 times 0 is 0. 0 times -5 is 0. And 5 times 0 is 0. So what we end up with, all of these zeros cancel out, and we just end up with the distance, sum of the products of the distances being -25. So what we did is we took our distance, we got our distance for each person, did both distances, we multiplied them, that's these black numbers, and then we added them all together to get our -25. To get our denominator, what we're going to do is we're going to take our distance from X and square it. So those are our blue numbers here. So -5 times -5 is 25. 0 times 0 is still 0. That's here and here. And then 5 times 5 is 25. So if we sum up our distances down here, then what we're getting is 50 total. So 25 plus 25 plus 0 plus 0. So that's our sum of squared errors once again. And we get a 50. All right, so we got our numerator and our denominator. All we gotta do is divide them together. -25 divided by 50 is -1/2, or if you like the decimal, -0.5. That's our slope. We just calculated it. If we plotted our slope on this graph, it would look like this purple line here. Now, do you remember the interpretation of the slope? What does it mean about the relationship between how many hours of TV you watch and what your quiz grade is going to be? Write it down and see if you're right later. All right, so we have our slope. Let's figure out where the intercept is. We can substitute into our formula instead of, we can change around our formula a little bit, substitute in our means, and we're going to get a 7.5. You can also see that on the chart if you look at it. There's a 7, it crosses the x-axis, the y-axis at 7.5, right there. But here's the formula for it. The mean of y minus the slope times the mean of x. All right, so now I want you to write down your interpretation of the intercept in terms of watching TV and quiz scores. And then you'll see if you're right on the next slide. All right, so here's the equation for this, the line for this set of data that we've been working with. Y equals 7.5 plus -0.5x. 7.5 is our intercept and -0.5 is our slope. Here's those interpretations I asked you about. For the intercept, we say that when you watch TV for 0 hours, your quiz grade, we predict that it's going to be 7.5. And then for every additional hour that you watch TV, your quiz grade is going to decrease 0.5 points. Just a note, you could also say it increases -0.5 points. Some people, it's easier to say decrease when it's a negative number, but it doesn't really matter. It's just, it means the same thing. Basically what's happening is that, you know, people who are not watching TV are doing pretty good on the quiz, but the people who watch more and more TV, they're not doing quite as well. That's what we're learning from this data set here. All right, before we leave this section, let's talk about how this fits with the linear model. If our model for the line is beta 0 plus beta 1x, then we add that into the equation for the model part, and then we can have the error here. So for each actual value, it's going to be the equation of the line plus some error. And then our error is still going to be actual value minus the predicted value. All right, but yeah, like where's the error in this model? We didn't talk about that at all. We didn't calculate any error. All right, let's get to that part. So with this example, we've shown how you get the line from the set of data, but the linear model is about minimizing error. So we need to figure out how much error there is in the model. And do you remember what term we use for the error? The mean square error. All right, so this is the formula we use to calculate our mean square error of nuggets. For regression, we're going to use a slightly different equation. But let's take a look at the top part, right? So error is the actual value minus the predicted value. And that's what we have right here. The actual value of y minus the predicted value of y hat. We square each of those values and we get the sum, right? So that's the square and that's the sum. That's the same thing we did before. So for student 1, we predicted they would score a 7.5 for watching no TV. That's the intercept. But they actually scored a 2. So we under-predicted their score. They got 2.5 points higher on the quiz than we predicted they would do. For our student over here, who is perfectly average, we predicted that they would get a 5 on the quiz, and they got a 5 on that quiz. So our error is 0. But for this kid down here, they watched 5 hours of TV, and we predicted that they would get a 5 on the quiz. They got a 0, so we definitely overestimated their quiz grade here. And then for this kid, we predicted that they would get a 2.5 on the quiz, but they actually got a 5, so we didn't do, so we under-predicted their score. So if we are going through this, so we got an error for each one, and we squared all of those. Oops. Then what we would get is these squares, 37.5. Then what we have to do, instead of dividing by n, we're going to divide by n minus p. P is just the number of variables, and that gets to that degrees of freedom that we're going to talk about in a little bit later. So we just do n minus 2, which ends up being 2. So we divide 37.5 by 2. Our mean squared error is going to be 18.75. So the average distance of each person from what we predicted, squared distance for what we predicted, is 18.75. The total amount of sharing that we had in our model is 18.75. So what? Is that a good number or is that a bad number? We don't have anything to compare it to, so we can't actually say. We need some sort of null hypothesis. And what is usually the null hypothesis in a statistical test? Think about that, and we'll see what to do with this number, 18.75, a little bit later. So that is how you get a line, how you calculate the slope and the intercept, and then what the relationship between that line and the mean square error